All right, so we'll go ahead and before we solve this whole thing, we'll just do one of these examples at the bottom, just so you guys can get started on the right foot. So which one you want to do? 2, 3, 4, or 5? 4? Okay. All right, so looking at number 4, you got two options. You can solve it through substitution or through elimination. Honestly, for this one, don't we have a variable already solved for? Yeah? Which one? Y. So I would probably pick substitution on this one. Okay? And here's what you can do. So since I've got y by itself, and I know that it equals 4x plus 5, I can just substitute that in my next equation for y. So on this one, I would do 4x plus 5 equals negative 2x plus 17. And this is going to help me to solve for x, and then I'll be able to plug it back in and get the number that y is. Okay, so we'll just solve this. We're going to add the smaller variable over, so I'm going to add the 2x. When I do that, 4x plus 2x is 6x plus 5 equals 17. Now I'm going to subtract the 5 over. I'm going to get 6x equals 17 minus 5, which is 12. And then divide by 6. And x is going to be 12 divided by 6, 2. Okay. So I've got x. Now I just need y. I can pick either of these equations. It does not matter which one. And plug that 2 in for x. So I'll just pick the top one. So y equals 4x, so 4 times 2, since x is 2, plus 5. So what is 4 times 2 plus 5? 4 times 2 is 8, plus 5 is 13. And that's it. You could go back and plug both those in and make sure that they work. But those should be your answers. And let's go ahead and do one like elimination just so you can see it. Let's go to number 3. Okay, so when using elimination, I want my x's plus y's equals my constants for both, and I want them to be lined up. Are these lined up? Yep, they're lined up. Do I have anything that currently will cancel? So will any of these x's cancel out, or will the y's cancel out? Does x minus 2x cancel that out to be 0? No. Does 2y minus 4y equal 0? No. So I need one or the other to be opposites. So I need these to be opposites of each other, or I need these to be opposite of each other. It really doesn't matter which one you pick. Sometimes you have an option, kind of like this one, okay? What I would do on this one, the easiest thing would be to just look at my x's. One of them is a positive x, and one is a negative 2x. If I want them to be opposite, which one should I multiply by, and what should I multiply by? The top by 2. Good, because that's going to give me a positive 2x for my first variable, which is going to cancel with the negative 2x. Okay, so since I'm multiplying, I've got to make sure I multiply to everything. So 2 times x is 2x. 2 times 2y is 4y. And what's 2 times 6? 12. Okay, so that's my new first equation. And now I'm just going to rewrite the next equation underneath. And now I've got my addition problem. So 2x minus 2x, I knew those were going to cancel out. What about 4y minus 4y? They also cancel out. So this whole side just becomes 0. What about 12 minus 12? Also cancels out. So here's what I'm left with. 0 equals 0. Is that true or false? True. So that means it's going to be infinite or no solution. Infinite. Remember, infinite solution is a true statement with no variables. No solution is a false statement with no variables. Okay? Questions on that? They're not always going to all cancel out. Okay? Like, for instance, on number 2, they won't. But if you would get them all to cancel out and you're left with a true statement, it's going to be infinite. If you're left with a false number statement, it's going to be no solution. All right, let's go ahead and we will finish solving the front page, and then you guys will have more time to keep working through the rest. So go ahead and flip to the front. So number 1 says to solve the system of equations by graphing. Okay? So in order to solve by graphing, I just got to start graphing, right? Is that first equation, is that in a form that I can graph? Negative 5x minus 3y? No. What do I need to do with that? What'd you say? Or solve for y, you mean? Yeah, so that way I can graph it. So how would I solve for y? Add 5x on both sides. So I end up with negative 3y equals 5x plus 12. Then I divide by negative 3, good. Okay, so I end up with y equals, I can just pull out that fraction, okay, so it'd be 5 over negative 3 or negative 5/3 x, and then 12 divided by negative 3, negative 4. Okay, so now I have something I can graph. What's the b value on that? On that first one, what's the b value? And then my slope? The slope is down 5, right 3, or up 5, left 3. It's an equation, so it should always have a solid line if it's an equation. Okay? What about this second equation? Is that something I can graph? Yep, what's the b value on that? And the slope? Yep, 1, so up 1 over 1. Okay, so there are my graphs. And my lines were not super straight, but if they were, they would have met at this point right here. And what is that point? Negative 3, 1. And that's your answer. Negative 3, 1. Questions on that? Okay. So we're going to go ahead and hop down to number 2. Did you solve number 2 through substitution or through elimination? Substitution, okay. Anybody do elimination? No? Okay, let's do substitution. Which one, or which variable did you solve for first? Y on the top one? Okay. How'd you do that? Add the 6x over. Good. So you just get y equals 6x minus 11? Is that what you got? Okay. And then what'd you do? Plug it into the second equation for y. Okay, cool. So negative 2x minus 3, my new y is just 6x minus 11 equals negative 7. How would I solve something like that? So I get negative 2x, negative 18x, positive 33 is negative 7. Combine like terms, negative 2x minus 18x, negative 20x. Subtract the 33, so negative 20x equals negative 40. Divide, and x is 2. Then what?
Plug that into your y equals 6x minus 11.
Yeah, you can go back and you can take that too. You could plug it into this, you could plug it into this, or plug it into your simplified one. That's a little bit easier. So I'm going to choose to plug it into this one. So it's just going to be y is 6 times 2 minus 11. So 12 minus 11 is just going to be y equals 1. Y equals 1. Questions on that? Did anybody do elimination on that? You did? What did you choose to multiply by up top? The bottom equation you multiplied by 3. Okay. Or you mean negative 3? Or did you do positive? Negative 3. Yeah, that works. You could have multiplied the top equation by positive 3, and that would have canceled out your y's, right? If I would have multiplied by a positive 3. Okay, cool. Let's hop down to number 5. Substitution or elimination. This one's a really easy one for elimination if you look at the y's. So one's already negative and one's positive. How can I make them opposites? Yep, multiply by the top one by 2. Anybody see that? That's what you did? Cool. Yeah. You did substitution. Okay, that works too. And let's watch. So Percy did substitution. I'm going to do elimination, and then I'm going to check our answers, and I bet we get the same thing. Okay? So that top one I'm multiplying by 2. 2 times 2x is 4x. 2 times negative y is negative 2y. And 2 times 11, 22. So then I just bring over that other equation. Set up my addition problem. My y's are going to cancel, which is exactly what I wanted to happen. So 4x plus 3x is 7x, and 22 plus 6, 28. Now I just got to divide by that 7. And what is 28 divided by 7? 4. Now what can I plug that x into? Does it matter? Nope. I could plug it into this original, or even the one I multiplied. Okay? I'm going to plug it into the bottom one, just because I haven't used that one yet. 3 times 4 plus 2y equals 6. 3 times 4 is 12. Subtract that 12. 2y equals negative 6. And when I divide by 2, what does y equal? Is that the same answers that you got for substitution? Good. Then we both did it right. Okay, so that's the first page. Go ahead and keep solving through this packet. You could get with a partner, and on number 6, one of you solve it through substitution, one of you solve it through elimination, and see if you get the same thing. Okay, so keep going. All right, so number 6, did you choose substitution or elimination? Substitution, okay. Which variable did you solve for, and in which equation? Y in the first one, so you just subtracted that 7x over to get y equals negative 7x plus 10. Now what? What did you do after you find the y? Plug it into the next one, right? So 21x plus 3 times negative 7x plus 10 equals 4. So now we end up with 21x minus 21x, because I'm distributing this 3, plus 30 equals 4. Well, what's 21x minus 21x? 0. Those cancel. Does 30 equal 4? Absolutely not. So what is this? No solution. Did anybody do elimination on that one? Yeah? So did you end up getting no solution as well? Good. So So elimination, you could have multiplied the top one by a -3, it looks like, to cancel out the first two variables. Yeah. And it would have canceled out the next two variables as well. So either way. Whoops. I don't know why it does that. Okay. Let's go ahead and we'll look at 7 and 8. So it's just solving the systems of inequalities by graphing. Number 7, is that first equation something I can graph without changing it? Yes, it is. What is the b value on number 7? -4. Put a point. What's the slope?
1.
Just 1. So up 1 over 1, up 1 over 1, right? We should be pros at graphing these lines. Dotted or shaded line?
Shaded.
Yep, shaded or solid. It is y is greater than, which means I need to shade. So looking at my line, I've got to shade up because these y values are greater than my line. So that means it's going to be this whole half of my line. You got that, Taylor? So since it's the y-axis, you shade up because it's greater. The alligator's eating it. Okay. Yeah.
I know the up and down.
You know the up and down now? Cool. Next one, the b value is 5. Slope is still going to be 1, so up 1 over 1. Or down 1, left 1. But this is y is less than, so am I shading above or below? Below. So I only need to shade what they have in common. I need to erase everything else. These are parallel lines, right? So we got to make sure our shading is right. What would have happened if instead of what we have here, okay, you listening to me? What if I flipped both of these signs? So what if this actually would have been less than and this one would have been greater than? How would that have changed my shading?
No solution.
It would have been a no solution, right? Because one of them would have had shading up here, one would have had shading down here, and they would have had nothing in common. Okay, but since they weren't like that, it was not a no solution.
Shouldn't the line be dashed?
Good call. Which line? The blue one? Yep, that line should be dashed. You are correct. The blue line is dashed. Okay. Next one. Is the first equation something I can graph? Yup. What's the b value? 1. Slope? -2, so down 2, right 1. That did not line up good. Hold on. There we go. Is this a dotted or solid line? Dotted or dashed? Is it y is less than or greater than? Less than. So I'm going to go ahead and shade lightly downward. Okay, make sure you shade light because you know you're going to have to erase something. One strategy I saw that Jason did, he just waited and did all of his shading at the end. That is totally fine, okay? Sometimes it's easier, though, to shade as you go. It just depends on how much you trust yourself doing these problems. If you feel like you're really good at them, then you're fine. But if you feel like you need to shade as you go, then go ahead and do that. The next one, is that something that I can solve the way it is, or graph the way it is?
No.
Nope, I need to solve it for y. So subtract the x over. 2y is greater than -x minus 8. Divide by 2. Y is greater than -1/2 x minus 4. So the b value is -4. Slope is down 1, right 2. Or up 1, left 2. Dash or solid? dashed. And this is y is greater or y is less? Y is greater, so just what they have in common is just going to be this part right here. I need to erase what they don't have in common. Guys, so Rachel's question was, since we divided, should we flip the sign on that second equation? Well, since it was a positive 2, we do not flip the sign. You only flip the sign if it's a negative number. Okay? Cool. All right, let's go ahead. How many of you guys think you got number 9? You're feeling confident about number 9? How many of you haven't started number 9? Okay, I'm going to give you about 3-4 minutes, get through number 9, and then we'll go through that. All right, let's go ahead and solve number 9. That first one, how would I graph that? On number 9, get to it. What's the b value on the first one? -5. And the slope? Up 2 over 1, up 2 over 1. Or down 2 left 1. Is this a dash or a solid line? Solid. Shade above or below? Above, because it's greater than. Next line, x is less than or equal to 5. What's this one? What does it look like? Should I put a point on 5 at my x or my y-axis? X, because it says x is less than 5. So right here. Is this going to be vertical or horizontal? Vertical, VUX. It starts with, or it has, yeah, it starts with an X, so it's going to be a VUX. It will be vertical. Is it X is less than or X is greater than? Less than. So that means on my x-axis, what values are less than my line? And only shade the ones that the other one has in common. So this part right here, I'm going to go back and I'm going to erase this little tiny triangle of shading. Okay? Last line, can I graph that the way it is? No, what do I need to do? Just subtract the x over. Gives me y is greater than -x plus 1. B value is 1. Slope is down 1, right 1. Or up 1, left 1. Dash or solid? Dashed. And it's greater or less. Greater. So I'm just shading above the line where it has in common with the other. I'm going to go back and I'm going to erase what's down here. Okay, questions on that? How many of you got that one? Look like quite a few. Good. All right, number 10, same deal, still solving inequalities, except this time we've got a part B. It wants us to circle the ordered pairs that are solutions to this. So we'll start with the first equation. Can't graph that the way that it is, or inequality, not equation. Can't graph that the way that it is. What do I need to do? Subtract the 2x. So y is less than or equal to -2x plus 3. B value is 3. Slope is down 2, right 1. Dash or solid line? Solid. Because that is less than or equal to. And since it's less than, that means I'm shading Up or down? Down. So this side of my line. We'll get there. We gotta graph the other one real quick. Okay, the next one, the b value is -5. Slope 1/4. Dashed or solid? Dashed. And greater or less than? Greater. So just this part right here. And I'm going to go back and erase below it. Okay. Everybody feeling confident on graphing systems of equations? Anybody still confused on that? It's a big, big part of your test. So please make sure you're good on that. Please ask me any questions if you have them. It is a bunch of graphing. Yep. Okay. Part B, this is something that we briefly talked about in the notes, but it will also be on your test. So you've got to do part A right to get part B right. So please make sure you're good on the graphing. Okay, it says a circle 3 ordered pairs that are solutions. So basically all you have to do is plot these points and see if they fall within the shading. Okay, so we'll start with the first point, 3, 0. I go over 3, and it's going to be on my x-axis. Is that within the shading? Absolutely not. Put an X through it. Okay, the next one is -3, 0. So starting in the middle, going left 3 on my x-axis. Is that within the shading? Yes, circle it. 0, 0, that's my origin. Is that within the shading? Yep. Okay, these are the two tricky ones. The last two. 0, -5 is going to be this point right here. Is that on a dotted or a shaded line? Dotted. So technically that's not within the shading since that's not a shaded line. So that is going to be a no. But what about 0, 3 right here? Why? It's on a shaded line. So those are your 3 points that would be solutions. Any questions on that? Okay. What time is it? All right. We'll go ahead and do this, and then we'll have the last little bit of class for you guys to ask questions if you have them. Bobby biked 4 miles last week and will bike 6 more miles per week from now on. Jaden biked 9 miles last week and will bike 5 more miles per week from now on. So I feel like we should underline the things that are important. It wants us to create a system of linear equations that can be used to represent this situation. So in this whole unit, linear equations are in the form of what? Y equals mx plus b. Y equals mx plus b. So if I'm creating a system of linear equations, how many do you think I need? Yeah, we've dealt with ones that have had 2 or 3, but I only have 2 people here, so I'm probably only going to do 2. Okay, think about this. Think about in this equation, what would be the variable that you're multiplying something by? And what are you just adding at the end in both of these? So we'll start with the first one. 4 miles last week, 6 more miles per week from now on. Y equals 4x plus 6. Raise your hand if you agree.
That's what it is.
Okay, so Kaylee said y equals 4x plus 6. Raise your hand if you agree with that. Raise your hand if you think it's something different. Ooh, what do we think it is, Jason?
6x
6x plus 4. Why would it be 6x plus 4? Because it's 6 miles per week, okay? And we said, think about the one that's being multiplied by something. So 6 miles would be 6x. The 4 from last week, that's not changing, right? That's not being multiplied by anything. That's just 4 miles last week, okay? And then what about my next equation? King, help me set it up. What'd you put for Jaden's equation? Y equals 5x plus 9. Raise your hand if you agree with that. Good, good, good. 9 miles last week, just being added at the end. 5 miles from this week forward. So that's being multiplied by your variable. What does that x represent? What am I multiplying by? If I'm saying 6 more miles per week and 5 more miles per week. Weeks, right? So x is just going to equal weeks. What about y? Miles or total miles, right? Total miles. All right, part C. This one requires a little bit of thought. After how many weeks will Bobby and Jaden have ridden the same number of miles? Or let me even reword that. How many weeks will Bobby and Jaden have ridden equal number of miles? What do you think we'd do? Great. Percy said set them equal to each other. That is correct. So we're just going to write 6x plus 4 equals 5x plus 9 and solve for x. Because we're solving for weeks. How would I do that? Yep, subtract the 5x. And then subtract the 4 over. So x is going to equal 5 what? Weeks. Make sure you label it. I might count off for that on the test. I probably will. Make sure you label it. Then it says, how many miles will they have ridden at the same time in your answer to part C? What do you think we should do? Plug it in for y. Does it matter which one? No, and let me show you why. You don't have to do both on the test, but I'm going to show you. 6 times 5 plus 4. 6 times 5 is 30, plus 4 is 34 miles. If I would have chose to plug it into the other one, I would still be plugging in 5 for x. 5 times 5 is 25, plus 9 is still y equals 34 miles. So it does not matter which one you plug into, you're still going to get the same answer. 34 miles is how many miles he'll have ridden in 5 weeks. Okay? Questions on that? Test problem is very, very similar to that. Very, very similar to that. So I would study that if I were you.